Hello guys, today we're going to continue complex numbers. We're going to focus on examples 3 and 4, pretty much multiplying complex numbers and rationalizing a complex expression. With these two examples, you have to know how to add, subtract, and multiply complex numbers. So let's get into multiplication. Now let's say, for example, they give me the following complex numbers. And again, this is example 3 in the book. I'm given this and I'm told to multiply. Many students like multiplying across. I don't multiply across. I multiply top to bottom, pretty much just like regular multiplication. So what I do is I just put one number above the other and I do a normal multiplication. Now, there is a tricky part, so I need you guys to pay attention. Here, when you multiply these two, here's where more students get confused. You multiply the number times the number. -4 times -3 is +12. And you also have to multiply the variables, or in this case, the imaginary unit. Imaginary unit times imaginary unit is imaginary unit squared. Many students multiply the number properly, but they forget that they also have to multiply the variables. Okay, so it becomes I squared. Then I multiply -4i times 2. I multiply the number times the number, -8. And the variable by itself doesn't have to be squared. It becomes -8i. Now I finished multiplying this number with both of my top numbers, so I move on to my next number. Here, 7 times -3 is -21, and I times itself, because there is no other I, is I. And remember, we put like terms one on top of the other. I squared, I. Now all I have to do is multiply these two. 7 times 2 is 14. After you multiply everything, we are going to add 12i squared minus 29i plus 14. You're still not done. Remember, complex numbers look like this. I, a real number and an imaginary part. A real part, imaginary part. Here I have a real part, an imaginary part, and an imaginary part squared. All you have to do is do the following. 14 minus 29i plus 12i squared. Remember, in the previous video, we saw that I squared is the same thing as -1. So I'm going to turn this I squared into a -1 that will multiply the number that was together with it. So +12 times -1 is -12. So this expression actually becomes the following. -12. Now I join like terms, and I'm left with 14 minus 12, 2 minus 29i. It looks like a complex number. Many students do not turn the I squared into -1, then multiply and combine. If you don't do that, you're wrong. You're not going to be able to finish. So make sure you remember that. That is the number one mistake students do. Don't be that person. Switch your I squared into -1. Don't be that person. Let's continue. Now, it's incredibly important that you know how to multiply, because the following steps depends on addition, subtraction, and multiplication. If you don't know how to do these three, you won't be able to rationalize. So, again, remember how we rationalize roots? You multiply the numerator and denominator by the same number, and it doesn't change. I'm going to do a brief review of rationalization, but pretty much I'm told to simplify the following expression. 1 minus 2i. Now last year we rationalized we were rationalizing radicals. We don't want radicals in the denominator. Well, now we're going to be rationalizing imaginary numbers. I don't want that imaginary number in the denominator, so I'm going to do a small process called rationalization to end up with the imaginary number only in the numerator. So remember, this is a division. Any division, you can multiply by the number 1 and it doesn't change. Again, any number multiplied by itself or by 1, any number multiplied by 1 is equal to itself, doesn't change. And remember also that at the same time, any number divided by itself is also 1. So I can multiply times this fraction, not change anything. However, this isn't really going to help us. What I'm going to do is, you're going to pick the denominator as is. And all you have to do is change the sign. So if I have 1 minus 2i, down here I'm going to have 1 plus 2i. And up here, I have to have the exact same thing. Because remember, any number divided by itself is equal to 1. And if I multiply anything times 1, I'm not really changing anything. So all this process is to move this I here to the numerator. So I'm still not done. Now people are going to say, teacher, so how the heck do I continue working now? Bueno, here you can see a little bit of pattern recognition. If you were to multiply these two, it's pretty much like the factors of a difference of squares. You're always going to have the exact same expression, only with the sign changed. So it's pretty much like a difference of squares. Remember, this used to be a difference of squares, x plus 6, x minus 6. So right now, these things are like the factors, and what you're going to do is, you're going to multiply them both to end up with kind of like the original expression of the difference of squares. Now, when I multiply these two, all you gotta do is square the first. 1 squared is 1. You always have to put a negative here. Always put a negative sign. Don't even have to ask, don't even have to think. It's always gonna be negative. You square the first, put a negative, and then square the second. Remember, 2i squared, the exponent applies both to the 2 and to the I. So I'm going to end up with 4i, let me put it like this, 4i squared. Now remember, as soon as you see an I squared, switch it to -1. That takes care of my denominator. Now, what do I do in the numerator? All you gotta do is multiply, just like we previously multiplied. I'm gonna have 5 minus 3i. Let me go ahead and erase this. 5 minus 3i times 1 plus 2i. Let me confirm. Yeah, 1 plus 2i. Let's do the multiplication again. Again, good practice. 2i times -3i. The numbers multiplied give you -6. The variables multiplied give you I squared. This times this. The number gives you 10. The variable gives you I. This times this. The number gives you -3. The variable gives you I. This times this. The number gives you 5. So you're going to end up with 5 minus 7i minus 6i squared. I'm going to turn that I squared into -1. When I multiply, this becomes a positive 6. Again, that eraser really doesn't want to work today. It's jumped off the board like 2 times. When you combine these two, you're going to end up in the numerator with 11 minus 7i. Many people will say, and this is a good question, many people say, Profe, but when I multiply, I'm left with something. It's not in standard form. That's fine. This isn't a polynomial. This is a complex number. It doesn't matter if the I squared is left at the end. You're going to change it into a -1 and then order it. In complex numbers, the real portion is first, the imaginary portion is second. This is not a polynomial, so we're not dealing with degrees here. Coronavirus test came back negative. Don't freak out. So all you got to do now is, let's multiply this part. -4 times -1 is +4. 1 plus 4 is 5. So you're left with this expression. If you reach that expression, you're pretty much done. Nothing else needs to be done. However, some people choose to just break it down into two parts. Actually, since we're dealing with complex numbers, not a normal fraction, please break it up. 11 divided by 5 is 11/5 minus 7i over 5. Why did I choose to break it up? Because again, we're dealing with complex numbers, not an actual fraction. This is the real portion. This is the imaginary portion. If I leave it like this, it's still jumbled up. It's no good. That's pretty much it for today. See you tomorrow.